to study Godot's build system. I think I'm just gonna study the files and maybe try to. I created another project and I'm gonna try to. I'm not sure if I'm gonna do this today, but eventually I'm gonna try to rebuild Godot from scratch. So just copy gradually the files that they have there and build everything from the beginning so I understand how it works. So first I'm going to try to understand how their build system works. They use this tool called scons from Python. And as far as I understand, there's a bunch of Python scripts that allow you to, they probably call CMake under the hood and allow you to compile everything. So they use a bunch of third party libraries, and I want to figure out how they do it. I'm just gonna wait till it shows that it's streaming there. Okay. So I remember now why I decided to I was trying to do I wasn't aware that I was trying to do this, but build a custom engine from scratch. So first I was building the rendering, and then I got to the point where I had the parts of the rendering that I thought that I'm going to need now. And I got to the part that I'm going to build I was going to build the engine. And for that, I was watching a playlist, and then I thought that I should try to implement what he does on the playlist. And as I was trying to implement this, I got some errors here, and I was feeling that this is not very... It might be a possible way to do it, but it's not very good. And the reason why is because I explained this on the last stream that I did. I did this flowchart here to represent the way that I was thinking about doing this, and the way that he recommends to do it, which is you create an engine class, and then inside of the constructor of the engine class, you create a shared pointer for the default scene you're gonna have. And the default scene is a derived class from an abstract class that contains the scene structure. And inside of the scene, you're gonna have logic somewhere that's gonna call a function from the engine itself. So the scene receives the engine as a pointer as well, so that it can access the engine and call the function, which is the function to change the scene. And then that function, you would have another scene, and then you pass that scene to that function, and then that's how you change the scenes. So this pattern is called finite state machine. But the reason why I didn't like this is because on the series, he doesn't explain the nuances of it. He just goes, as far as I remember, he doesn't show the code for the engine itself. So the main nuances that I was thinking about is how exactly should I pass the instance of the engine as I create the scene, and at what points should I create the scene exactly. And the main problem that I was having, which I did think about this before, but I thought that maybe it's fine, and it's possible that it is fine and it is a pattern, but it's, I don't know, it felt kind of weird to me because it creates this circular dependency thing where I have to declare the engine class on the scene, and then on the engine I have to declare the scene class. And the types are very confusing because, especially, and this is a problem that I had before as well with C++ that I'm still not, I don't know very well how to deal with this, which is usually, there is an example here actually that I got from 3PP. So usually creates, there's going to be a lot of instances where it's necessary to create, not necessary, but it's a good idea to create an abstract base class, which is a class that holds a template. It's also called interface, which is just the rule sets for creating other classes that are going to derive from the class to make it easier to manage everything. So it's just like the idea of a concept, for example. So you can think about a human being as being the base class, and then each human being is going to have its own unique attributes, which are going to be derived class from the base class, which is the overall template of what it means to be a human being. But the issue with this is that whenever you're gonna have other classes that are gonna interact with this base class, there's gonna be a problem with the type, because you're gonna have to specify the type of the base class, but in reality, what you're gonna be passing is the type of the derived class. And on C++, usually when these things happen, there's other situations like that where you have to push one of these classes to a vector, for example, or to a queue. Then the queue is gonna have to be declared with the base class, and then you're gonna push the derived class for the queue. Then the name of this is object slicing, because you're passing the object as a type. So in this case, I have the material class, which is the base type, and I would pass the mesh basic material type, which is a class that derives from the material type. So let's say I have a queue. I would have to declare the queue as the material type, because I'm not gonna know what kind of derived class I'm gonna pass to the queue, so I have to declare the queue with the material type. But in practice, I was gonna push the mesh basic material type. So what that means is that the compiler is gonna slice everything, as far as I understand now, everything that is specific to the mesh basic material from the queue, and is gonna store on the queue the version that only has access to the material stuff, as far as I understand. So there is some nuances. I'm not really sure about that, but it is just a confusing thing to deal with. And here it's kind of like the same, but it's more complicated because there's the circular dependency thing. And then all of that made me think about studying other game engines, because to understand like if there's other approaches. And also he mentions on the playlist that I was watching that this is not the best approach, just for educational purposes. So I was curious about what actually happens like on the engines that are the most up to date and use advanced techniques. And because of that, I went back to study Godot. I searched for some engines, but then after some research using ChatGPT and just using search engines and reading a bunch of stuff, I got to the conclusion that probably the best one is Godot, which is open source. The other two is Unreal Engine and Unity, but they are both closed source. They are open source, but then there's some stuff about royalties and whatever. So like Godot is the only one that is actually fully open source. And that's the reason why I decided to study Godot again. So this is the issue that I'm getting on this project that I'm building, which is unresolved symbols, and I think it's because of the way that I'm declared here. This is called a for declare. So you just declare the class on the header file, because usually it's not recommended to import headers on other headers, because C++ has this thing called translation unit, which is every C++ file is considered to be its own island, let's say, and then the linker connects them after. So the C++ files are not aware of the other files. So if you include headers on other headers, there's problems because there can be multiple definitions, and because the C++ is not aware at the moment that it compiles the C++ files, you get some error of multiple definitions. So what people usually do is to do this thing called for declare, where you just specify the type inside of the file, and then because you're including on the CPP file the header, then as it links everything, it's gonna know that this is not actually this class. It's just gonna point. I think that's what's happening. But maybe that's the problem I have here. I'm not really sure. And the other issue I was having here is that I was thinking about, because of the way that I did the renderer requires a scene and a scene object and a camera, so that it handles the visualization, which is kind of confusing. So I had to change the name as well, because you have the main scene, which is the scenes of the application itself, and then I have the scene of the renderer, which is how it's gonna structure the scene tree to determine what's going to be visualized. So the confusion that I had was I thought that I have to initialize them inside of this class here, because if I initialize them on the engine, then all of the scenes are going to have the same renderer. And I'm not really sure if that's a good idea, because then like I have to delete everything from the scene and load everything again every time there's a scene change here. So I have to delete everything on the renderer and put the stuff of the other scene on the renderer. I thought maybe it's probably better to create one instance on each scene, and then I can let the state saved, let's say. And then every time that I change scenes, it's gonna be faster, but I'm not 100% sure if that's a good idea or not. Well, that's the reason why I started to study Godot again. And then I realized and I remember the reason why I decided to go the route that I did. And it's mainly because all of the videos on Godot are people explaining the script language. So as far as I understand, the way that it works is Godot is an engine, and then they use the engine to build an editor. So the editor is built with the engine. But what the editor allows you to do is to develop the game. So it's just like an application. And Unreal Engine and Unity works this way as well, where you use an editor, and then because it's much easier to create the game, and the game is very complex, if you use the GUI to create all this stuff. And all the tutorials are related to the editor, not the engine. And I felt that this is a big problem because in my mind, it's kind of like the same thing that happens with no code, that there's obviously always this trade-off that if you use the editor, you're going to be faster, but then the issue is that if you don't understand what's happening, then you, in my mind, you're not really becoming a better game programmer. You're just becoming better at using the software. And that's the thing that I really didn't like about using Unreal and Unity as well, because it felt like I wasn't going to learn anything. I was just going to learn how to use the software that they built. And then the issue is what happens if you lose the ability to use their software. So how fast are you going to be able to build everything from scratch? And how much do you understand what's actually going on under the hood to create everything? So this is the kind of thing that I want to avoid, but I'm not 100% sure what path I'm going to go with, because I think it's also fine. Like, probably what I'm going to do is just because to build an engine like this is very hard and it takes a lot of time. So obviously it makes sense to not build everything again and to use the stuff that they did, but I also think that it's very important to know what is going on under the hood. So this is the idea that I have now, and it's kind of the point where I'm at. I created these steps here, and already I went through their documentation, which by the way is very good. I really like the stuff that they did on the documentation. I wish more people would do stuff like this, which is to create the flowcharts. They have this thing here on some pages, and they have these flowcharts of the dependencies of the classes. That's very good. It would be even better if they had flowcharts showing the connection of everything, but this is already very good. So I really like that. And this is the picture for the engine architecture. So most of the documentation, it wasn't very good for me because they are just explaining the scripts, but obviously it makes sense because that's what most people are probably going to use. But I was more interested on this part here, which is engine development and ways to contribute. So somewhere here they have the steps of teaching you how to build everything. And basically, it's actually very simple to build. But I don't like the fact that I have to learn another tool. But I think this is just a problem with C++ that is very bad. The build system on C++ is like shitty. So I think it does make sense to use this tool in Python, but then it's an additional thing to learn. And that's kind of where I'm at as well, because I was thinking about, like, is it worth it to learn this and then start implementing this on every other C++ project that I create? Or should I continue to build with CMake and then just translate from Godot all the stuff that they do, choose CMake so to make it work? But the issue with that, and the reason why I think it's probably better to just go with the way that they did, is because I tried to install the third parties here with CMake, and I really didn't like some of them is kind of, it depends on which approach you use, but it can be very hard to deal with CMake. And the biggest issue, and the thing that I'm not sure, is that, like, the thing that is good about Godot, and I'm not sure, is that it apparently works for a bunch of different operational systems. So that's where it starts to get very complicated as well. And I didn't need to deal with this yet. So I think it's just probably smarter to go with the way that they did it, because they probably spent a bunch of time already. And well, another reason why I decided to study Godot and try to implement Godot now is just because of how many things I knew I would have to do that eventually, but they already did everything. So I think it's just much smarter to look at the way that they did, because they probably failed a lot, and now they have the more optimized version of everything. So if I can just study from what they did, understand what they did, and incorporate on the other thing that I'm doing, then I'm gonna save a bunch of time. But installing all these third parties with CMake is probably gonna be hell. So I think it's probably better to just try to understand what the hell they are doing to build this. But the way that you build it is just by using the scones commands, and then you pass some arguments. It's very similar to CMake. And then it probably is going to run. So one thing that I don't understand is exactly how you searches for files here. This is kind of my concern as well, to be honest, because like it might take a bunch of time to. The documentation has like 5 hours here of stuff, so it's kind of annoying. But I think that it looks for a sconstruct file here and some of these other Python files, and then it reads the code from them. And then whatever you put here is going to be similar to CMake, which allows you to tell the compiler what files should compile and what executable should build and stuff like that. So I think probably the best idea now and that I'm following. So I built the CMake project. They also have a parts of the documentation that explains how to set up on the Visual Studio Code, which is very nice. So I just got the code from them, the launch.json file, and the VS Code, the task.json file. Just basically this code. So you run the command that they tell you to run. I'm using Windows 10, so I just did the platform Windows. There's one thing that's it's kind of confusing, is that I built with these other commands here first, and then I was trying to run an executable there. It creates everything on the binary folder, the final files. But I was getting an error that it doesn't have a data or something like that. So this is kind of one of the parts that is confusing to me so far. But I think that, so there's one way to build where you're going to build a debug version, but that's only going to work after you build the game. So the first build you make, you're going to make the executable that actually runs the editor, which is the stuff that you're going to use to build the game. Then after you build the game with the editor, it saves all the files on another folder inside of the project on Godot. And then after you do that, I think you can build again with a debug. And then it's probably going to allow you to not only debug the editor, but also debug the game that you did. So if you run these commands here, I think it only works to create the debug executable after you build the game. If you want to debug without building the game, then you just copy this task.json, which is just going to use a shell to call scons, and then pass this argument here to create the developer or the debug version. Then after you do that, it's just going to, if you're using VS Code, you're just going to launch just going to execute whatever you put here. And here you put the path of the executable that it was created with the dev version, which in my case is this name here. And probably it's going to change depending on the operational system you're using. So yeah, I did this. And then I ran a little bit with the debugger to step through it and put some breakpoints. And I wanted to do that initially to get an idea of how everything works. There's some things that are probably going to be very difficult to understand, but they created their own. Like one thing that I really like and that's going to be interesting to dive deeper into is that they created their own string class, and then they created their own hash map class, which are hash map and hash sets. And the reason why there's a video of the lead developer, I forgot his name and his YouTube channel, but if you look into the about page on Godot, then I think maybe I should do that now. There's a video on his YouTube channel that he explains that the reason why they do this is because the malloc and the functions to allocate memory on C++, they're not very optimal for speed because they have to generalize and there's some other nuances. So they decided to sacrifice memory in order to gain speed. And the way that they do that is by creating their own version of malloc and other variations of that only allocate memory and they never deallocate memory. So it only grows the memory, but then you don't have to reallocate the other times. And that's the main reason why they created the other classes that they created. And So this is pretty much the editor version, and I created a little program here, but I was just trying to see like how it works. Probably what I'm gonna do as well. So I think the idea that I had is to now just try to figure out the build system. Then I created another project where I'm gonna start from scratch. Like I said, try to copy the files that they have on Godot. To try to build the system from scratch to see if I can understand how all the files work. Then once I get to the point, or maybe halfway through, once I understand better how the build system works, I think it's probably a good idea to just follow the tutorials again and then try to build a game by using the engine that they have, because that's going to allow me to understand more. I already watched a bunch of videos, but it's still kind of confusing. So you create nodes here, and then they have their own language, which this is also something that I didn't like that much. So I would like to see if I can, instead of doing this scripting language that they use, it's called GD, I think, GD script. I want to see if I can, there is an extension to do it with only C++, but I want to try to understand how it works. Yeah, but basically you have these nodes here, and as far as I understand, the way that they create the scenes on the engine is by using a server. So they create a scene tree, and the scene tree is not only each scene it's going to be a node on the tree, and the scene itself is the renderer that I have on the other project. So it's just a tree, and the way that they change from scene to scene is going to be with a server that the engine creates, as far as I understand. So the functionality that you put on the script is the thing that sends the signal to the server, and then the server does some stuff and then changes the whatever active scene is going on. But I think that the way that it works is that you just create these nodes here, and then you create scripts for each scene, and you create meshes based on whatever you put here, and then you save the scene, and then you save on a folder. Then once you have the whole game, it allows you to play the game from here, and then I think you have to build again, and then if you want to debug. So that's probably what I'm going to do after I do the build system. Just to get an understanding of what's going on. Then after I do that, then I can try to build. I want to build without using the GUI. But I'm probably going to go back to just use the stuff that they did, because it's easier and saves a lot of time. But ideally, I want to understand everything that is going on under the hood with the engine. I'm not gonna do this now, but the main thing that I'm trying to understand is, so first the optimizations that they make, and how exactly they connect the scene tree with the engine, and what is the design there. So understanding the malloc stuff and how they do that. And so probably what this function is doing is just using these built-in functions from Python to figure out the location of the module and then execute the module. just these files here. So it creates the namespace probably for the modules and assigns to this file here, I think. So the name and the path. And the path is probably from the relative path from, it has to be the relative path from the build folder. This is this files here probably. So one thing that is kind of hard on the beginning to figure out is what is the separation of this stuff that comes from SCons and the stuff that they put there, like the custom code, to figure everything out. So the main thing that I'm interested on is I'm probably just gonna copy because it's easy. It's easier to do that. So just gradually copy everything that they did. But I want to see if I can do it incrementally though. So like I'm forced to think about how it works. But the main thing that I want to figure out first is how exactly they load all the third-party libraries, because I remember trying to do free type. I think they are using free type for the tags, and it's very annoying. But there is one thing though, is that if you do it with GitHub declare command, which is gonna download the thing from GitHub, then it becomes a lot easier to set up CMake. But I don't like that approach very much because you rely on having GitHub to build. That's not very good, in my opinion. So the concern that I have is that probably they're doing the same thing with SCons under the hood, where eventually it's gonna call GitHub declare some stuff like that, which is not very good. But I think it's probably just something you have to deal with because it's just easier to do it. Because there's always this trade-off, and the reason why these things like work the way that they do is because of the trade-off in energy. So usually people build stuff because it's easier, then it becomes the standard, but then the trade-off is that you become dependent on that. Is it not very good? And that's the reason why I don't like relying on no-code tools or stuff or AI. It's kind of like the same thing as building a wrapper on ChatGPT. Like you don't really own the stuff that you build, because the model is not yours. So I think the best approach is probably try to find the middle way, or understanding how it works, but then also at the same time doing some trade-offs, so you don't spend a bunch of time trying to figure everything out, because that's also not possible. Free type, they have free type here. This is something that something I thought that it's probably different, but now after spending some time thinking about it, I think it's very similar, which is the way that they do the objects. Because this is another thing that I was kind of thinking about, where like the main reason why I did this stuff the way that I did is because I started off with using 3JS on the front end to build everything. And I wanted to get something similar to that, because then I would have a more clear picture in my mind of how it should work. But now I realize that it's probably not very good, because like I'm gonna understand a lot more on how everything works. So probably I'm not really sure if the design that 3JS selected is the best one. So this is something that I'm thinking about, and I thought that initially I thought that I should try to keep my own renderer and then try to just incorporate the engine parts from Godot. But now that I think about it more, it's probably a better idea to try to do it with the way that they did it, because it's probably more optimized for C++, and the architecture is probably better. But now I realize that it's very similar, actually, as far as I know, in the way that it works, that everything inherits from this object class. So the biggest issue is the data structures and the algorithms that they're going to use on the object class. Because if they are very different, then it might be very annoying to convert the stuff that I have on the other project. But they should probably be very similar, so I think I should probably try to do it in the way that they do it. And I think the paradigm that they use is something called a voxel. And a voxel is kind of like a small, as far as I understand, small little cube that models each pixel, and then you can compose any object based on these voxels. And I think that's how they do it. So I think it's probably a better idea to try to understand how they do it, because it's probably a lot more powerful than the stuff that I was doing before. So, but then there's always a trade-off between if it's gonna be a lot of energy to do that or not. But I think it's probably pretty similar. Every mesh inherits from this object, This object has the geometry, which is going to be how the data is built to use on OpenGL on Vulkan. Another thing that I'm very interested on is understanding the Vulkan renderer. So the main ones that they use are Vulkan and OpenGL, I think. And there's another one, but I think the other one's for Apple or something like that. I don't remember. But Vulkan is more optimal, so. And now I think I'm gonna do the flowcharts on this website that I found here, which is better to do flowcharts. It's also free. It's app diagrams now. So I was building the initial parts here, but because they have this stuff, I'm not really sure if it's necessary to do them. I'm probably gonna build a little bit more of the flowcharts there, but I think it's probably better to just use the debugger and try to understand how it works. So the node 2D is for the 2D visualizations, and then the spatial is for 3D, which is on another this spatial 3D stuff. So all of them inherit from this node class, and then it inherits from the object, and the object is the one that has probably the material and the geometry. And there's some stuff about the server as well that I have to understand. Oh, from some of the code that I saw, also they take the TTF fonts from Windows system as well, which is also interesting. And another interesting thing to study Godot is that they don't use GLFW to open the window. They do this stuff with their own code, so that's also interesting to see. They call the Windows API directly. I think it just makes a lot more sense. The materials here, it just makes a lot more sense to do it from their thing. But I want to be careful, make sure that I'm not just understanding how the editor works and then I become dependent on that and I don't understand how everything is working under the hood. So I want to make sure that I understand everything. It's probably better to just do it from like everything and forget about that. I don't think that's the work that I did on that one was useless. I think it was very good to learn everything. But probably the way that they are doing here is more optimal, and they probably have the same functionality from the other one. Just have to figure out how they do it on their thing. What functions are the ones to change the model in the camera, stuff like that. And how they are building the shaders. One thing that they do a lot, that the parts that I've seen with the debugger, is that everything is a singleton, the way that they do it. And the way that they do the singleton is just creating a member variable inside of the class, which was something that I was thinking about here as well, how to do these things. But the way that they do it is just by creating, so it would be like here, create sing, and then a current sing or something like that, or singleton actually, they put the name like this. And then inside of the constructor, they assign this to this. So on the constructor of the class, they do singleton equals this. And it is kind of confusing to understand, but I think that's probably like the way to use singletons on C++. To create a pointer, a member variable that is a pointer to the class itself. And then when you initialize the constructor, you initialize the variable as the this, which is going to be the instance. And I think they use static as well. So static means that it's going to be global. So that means you're allocating the space in memory for one instance of the class, which is going to exist throughout the execution of the program. So it's kind of like a global variable. And the instances point to the same address in memory, I think. But usually you're only going to create one, which is the singleton. They do this on a lot of different classes. I'm gonna ask ChatGPT, but I'm pretty sure I understand what is going on here. So they're building a module manually, and then they're executing module. Just gonna be the files here. And then they're caching. As far as I remember now, I'm not really sure because there's been some time since I've seen this. But I remember that the way that Python imports modules or files is by going over the C's dictionary, which I think is the C's modules dictionary, and then they look at in some default places or something like that, and they use the built-in frozen module thing there to find. So I think they're just putting the instance of the module that they create here as part of the other modules from Python. I'm not sure if I can debug this. It's kind of the issue. It would be good if I could set up a debugger to step through and see what is going on actually, but because it's kind of weird here that has this while true. They're just only gonna stop when they guess an error. It's kind of confusing. So as far as I understand, what is going on is just creating these modules based on these names. It puts the name of the module here and what file is going to be called when you put the module. So after it does that, it imports the files here. So platform methods. So these are the architectures that it supports probably. this is kind of the thing that I'm kind of concerned because only the documentation has 5 hours here to understand. And the good thing is that the code is open source and there's a repository here apparently. But then like it got me thinking that I'm probably gonna have to, because like in order to understand exactly how it works, I'm gonna have to go over the source code of scones and understand how their code works, because I didn't like the documentation that much for now, but so I need to I need to clarify the questions that I have and then just try to see if I can look for them on the HTML version. I did the PDF version just so I could use the text-to-speech thing because this one is too long if it's loaded on a page. But this is kind of the problem, is because the documentation is only going to talk about how to use the thing and not how the thing works. That's the problem. So what I'm trying to clarify now is, like from the perspective of the program of scones, what is going on when you execute the commands on the command line. So as far as I can think right now, just based on first principles, probably what's happening is that inside of the code there's going to be some patterns that it's going to look for inside of the project, or inside of the directory you're running scones from. It's just going to loop through all the directories and files, and then just going to try to search for Python files that match the certain pattern. And then it's going to, then I'm not really sure what's going to happen. It's probably going to execute some other files and some other files. Like there's probably built-in functionality to parse those files, and that's the thing. So this is the reason why I asked there if they're about these arguments here, and that's kind of the thing that's going to be hard to figure out, I think. So this is the logic that I'm using to think about it. So like, because there is this curly lines here, or this, whatever you say this, is either a Python built-in function that I don't have because the IntelliSense can't figure out, or is something that scones uses. So my best guess is that what's probably happening is that scones is going to read the file and it's going to parse the file. And as it parses the file, it looks for these arguments here, or for these keywords that it has based on its functionality. And then if the code has the functionality, it's going to do whatever it does. So I guess I can look for this file, this thing here. There is some part of the documentation I'm trying to remember that they say that you don't need to install. So I installed scones on the global environments that I have on the computer by using pip install and then scones. And if you don't create a virtual environment, it just puts on the side packages of your main Python thing that you have on your environment variables. So I install that on that environment, and then I just run scones from there. But at some point they say, I don't remember where, that you can specify a path instead. You can download the source code and then specify a path and execute scones directly from with the path. Oh, it's here. No. That's probably on the user. So I want to understand the flow of execution. What is happening first? Because if I'm going to rebuild everything, then I need to know what file to do first and which folder and file to rebuild first, so I can copy the code. But the issue that is going to happen is that because everything is connected, then it's going to be really hard, because if I puts one file from the core, for example, then it's gonna depend on a bunch of different classes that rely on other files, and that's kind of the issue because then like I want to avoid having to import everything at once because then it defeats the purpose, obviously. So if I don't know how to make the distinctions of where to, what points to break it down the code, then it becomes very hard to gradually translate everything. Let's ChatGPT how to debug scones functionality. I'm gonna go over the points that the breakpoints that I did there very fast to show some of the functionality. There's a lot of code. It's very complex.
Sounds is a software construction tool that uses a Python-based scripting language for describing the build process. It doesn't rely on specific files to determine what needs to be built. Instead, it relies on the dependency graph created by examining the build script, typically named instructors construct, and the source files themselves. When you run Sounds, it reads the build script and recursively traverses the dependency graph to determine which targets need to be built and in what order. Sounds then checks the timestamps of the target files and their dependencies to decide whether they need to be rebuilt. That said, there are certain conventions and configurations that you can use in Sounds to help to understand your project structure. Synstruct and Sounds files. Sounds typically expects to find either a Synstruct file for the top-level project or Sounds files for subdirectories or components in your project directory. These files contain build configuration and describe the targets and dependencies. Source files. Sounds builds targets from source files. Depending on your project, these could be CC++ source files, C, CPP, header files, H, Python scripts, I, etc. Custom configuration files. Sometimes projects may include custom configuration files. For example, configure.ac for AutoTools-based projects that Sounds may need to read in order to determine build options or dependencies. Build output directory. Sounds may be configured to build the output files, binaries, libraries, etc. into a specific directory. This is often specified within the Synstruct or Sounds file using the variant gear function. Explicit dependencies. You can explicitly specify dependencies in the build script using Sounds functions like depends, requires, etc. to ensure that certain files are built before others. Overall, Sounds is quite flexible and can adapt to various project structures and configurations. Its dependency checking mechanism ensures that only the necessary files are rebuilt when needed, based on the information provided in the build script and the timestamps of the source files and targets.
I forgot to put timer here. I'll put 1 hour. I'm gonna take a break. trying to see if any. So as far as I understand now, the only special file is sconstruct. And that's the main entry point that sconst is gonna use. And the other files are probably built from this sconstruct here, from this stuff. I guess just looking here, I can already tell. And then they have other Python files on other. There is some points on the application where there is some code, C++ code, where it mentions some Python file. It is on another folder. And I guess that is the point, if I remember correctly, that this happens is related to the GD script language. It's probably related to that. Hmm. Maybe this one is also. Hmm. So the question that I have is why does it use this other use this function to load the other libraries but doesn't use to build this one? So this is the question. I think it's probably because it might be because the other files use stuff related to scones, but this file doesn't. This file just uses stuff from Python, so it's fine to import this one directly, but not the other ones. And that's my assumption. Guys, it looks like this is just like helper functions should deal with the folders. I just going over the files, probably getting the source files. I'll look for some different music. So I guess it goes over all the other modules that these modules depend on, and also puts them on the sys modules dictionary, and then it breaks on purpose here. Once it's gonna be a value error when you don't have the parent module, so that means it traversed everything. I think it's probably what's going on. Maybe, not really sure. So it's probably I think it's for these parts here because it's splitting with the dots, and the initial name is gonna be this one. It's kind of confusing. So I think it's building the path, the relative path using the dots. It's probably what's going on. The honest like feeling that I have about all this is that it's just like duct tape solutions. It seems like the C++ build system is like built on the wrong way since the beginning, and then the solutions are just like putting a duct tape on the main fundamental issues probably. Which is very annoying, not gonna lie. Yeah, this is what I see. Yeah, this is what it's saying. So, what ChatGPT is saying here is that the main difference is that the modules that are loaded using the helper module function are the ones that rely on some scons built-in variables or other stuff, and the ones that are just imported normally are the ones that only have Python code. So these ones are loaded on build time, I think, or on runtime, and these are loaded before, maybe. No, I'm not really sure. This one actually, because these other ones are from here, the methods as well. So how does it know? So arguments is a default dictionary that Scones uses. So at that point, how does it know that the target variable is going to be can be equal to editor? Well, I guess it's just from the command line then. So if you pass the editor on the command line, then this is gonna be true, and it's gonna load these other modules. So they're probably making based on the command line arguments, whether you're gonna make a build to builds with the editor as well, or some other stuff that's is not essential, but you can have if you want. Values of variables should be passed, maybe specified in the command line. And so if you pass the editor variable, then it's gonna, I think I understand. So if you call this with target equals editor, probably, then this is gonna be true, I think. I was gonna ask ChatGPT to confirm. Pretty sure that this is what's happening. But this is gonna read all files. There's also another, I was gonna do that before. There's another also very useful, very helpful video from, I think it's the, I'm not sure what he is from Godot. Maybe lead engineer or something like that, but I'm gonna find the channels. So if you go on about here, that's what I did. Just put the names of the people on YouTube. So I think this guy here has a YouTube channel and this one as well. Or the same one. So is this one and another one? That they explain the files on the source code. So this is one of them. And then on this video, I don't. Platforms are the different contains the different logics for different platforms, and I think it's gonna be the main entry point, and he explains on these videos here. And the other guy, I think, is the project manager. I don't remember now, but. So the way that it works is that on the platform folders, you have the main platforms that it supports. Android, iOS. I'm doing with the windows now. And I think that this is the entry point that builds everything, and then you have a main function. I think, yeah, it's this one on the main folder. And this function in the beginning is gonna call a setup function, and the setup is gonna be so the first main function that is gonna run is the setup from the main class, which is the class that is gonna handle it's gonna initialize some operation system classes that are gonna create which is this class here, creates a singleton and creates the logic for dealing, I think for creating the server functionality, but also something else that I forgot now. Oh, the drivers. So these classes create the drivers. I think these are the classes that I did there on the flowcharts here. Have some stuff related to the drivers. And then after this setup function from the main class runs, then the other main function that is going to run is the one that creates or runs the loop. And the loop is the beginning of the entry point of the loop is very simple. It's just pulling events, then processing physics, I think, and then going over the rendering, something like that. There's two main functions on the main loop, but then those functions call a bunch of other functions. And the setup part is the one that is the most complicated from what I've seen. So the platforms are for the initial phase, I think. So here, I think what it's doing is probably just going over all platforms and checking for this detect file. So if it doesn't exist, just continuous. It's getting the relative path from this path, I think. And temporary path is the path to the relative path from the platform path, I think. Probably a class here. Oh, it's probably the file then. Not sure. So maybe this inserts the file as a module. Not really sure. So it's, I think the initial lines there are creating a module from the detect. So if the platform doesn't have the detect.py file, then it's just going to skip the loop. But if it has, then it puts on the path here so that you can import here. And this is just going to be the module from the thing here. So it allows you to access the functions. And that's what's happening. Or actually, if the platform is Linux, then they build like this. Let's see on the other ones if they have different paths. And it looks like it's just a name, so it's kind of weird. Yeah, all of them just have the name. Hey, what's up? Oh, it's actually the axe, not the... I confused the C with the axe. So now I understand. They're replacing this path. So they're building the relative path. I think I understand. So they're caching here with the name of the class. So they're mapping the name of the class with the path to the... They're just gonna replace. So one of the questions that I have is... I guess I can look in the documentation. Because I want to understand what exactly axe is. I think it's the relative path from the platform. So if it is the relative path, then the temporary path is going to be the relative path to that file, which is the detect file. So if it's not a directory, there has to be a file. And if it doesn't exist, then it continues. But if it exists, then it's going to build. So this should be detect pi, probably, maybe. I don't know what you mean by that, man. I guess maybe I can look at the source code. Yes. It would be great if I could just run the debugger or execute. Maybe I can do that actually, now that I think about it. And maybe I can put a print statement here and see. The thing is that it takes a long time to build everything. Uh, because there's a lot of codes and so I guess I'm gonna run the debugger first to show the breakpoints. Because the issue is that if I run this again, then it might break the stuff that I have there, and then I'm not gonna be able to run. So I'm gonna have to figure out. So I think it's probably better to show the breakpoints, and then after I do that, then I think is because it's just easier. I don't want to spend a bunch of time trying to figure out. So the main doubt that I have now is whether this is the relative path or absolute path, and what exactly is the path from. So I think like what makes most sense for me is that this is gonna be the relative path from the platform, and then it's only gonna continue on the loop whenever it finds the detect_py file. So that means it has to be. No, actually no. Now that I think about it, so X has to be the absolute path, I think. Yeah, so it makes sense because otherwise, like you wouldn't. I think that's what's happening. So yeah, never mind because this has to be the absolute path from to the platforms folder because otherwise it wouldn't be doing this here. So it's checking it to see if the detect_py is on these folders here, or each platform. So that's the reason why you replace this here, I think, because whenever you're on Windows, then Windows is gonna return the path. So I think that the function changes depending on whether you're using Windows or other operational systems. And if you're using Windows, it's gonna return the absolute path with the back thing. So it changes that to use this other one, but it's kind of weird that it uses two of them here. So I guess this is the absolute path to the platform. And then it's caching. The doc path is the name of the documents, probably, that it finds on this file. Yeah, so this is what is going on. So if the platform has documentation, probably, and classes, then it's going to return the name of the folder. And then it's caching that on the other map, on this one, based on the name of the classes. So it caches the name of the class with the path to with the absolute path to the documentation folder, I think. Let's see something. On the yeah, so it's caching the name of the. It's not really a class. It's the XML file that it's gonna use to create the documentation. It's caching the name of the file with the path to the folder. So it's probably gonna use this later to build the full path to the documentation, I think. Now this is a... I probably don't need to do this if I do it on the other one because I'm not gonna have documentation, I think. Probably what I'm gonna do first is to... So I'm gonna use this other project that I'm building now. Then I'm gonna reconstruct everything now, which is this one, this folder. So the goal is to translate the files into this folder. But this is probably not gonna be the one that I actually build the other stuff. I'm still not 100% sure in which path is the best way to go. If I should continue to do the stuff that as I was... Like, just merge the stuff that I was doing with the stuff from Godot, or to just reconstruct the Godot as much as I can on this one, and then use this, whatever I'm able to build here, as the starting point for the official thing that I'm gonna start building, I think. Probably the second option is the best. But either way, I think I'm not gonna probably build like documentation. I'm gonna view it. So yeah, I think this is the goal. Is I don't wanna use Godot. I wanna be able to change Godot in whatever way I want. That is gonna fit whatever I'm trying to build. That's the idea, I think. So I'm probably not gonna do it the same way that they do it here. So I think that I don't need to do this part here to build the documentation. Maybe I should figure out, or I should try to... Probably not gonna be able to do this, but at least try to simplify as much as possible. So, but I think that's probably gonna be a waste of time because it's very complex, the stuff that they have. It's probably just better to copy everything that they did and then start from there, as long as I understand what's going on. But I think if I try to simplify, it's just gonna be too much work, I think. So this is the part that's gonna handle the thing here. You put these arguments to specify what platform we're gonna build for. So it just uses the default custom tones for the version that I put there. Right. And let me figure out, continue to figure this part here. So I guess, obviously I don't know for sure what this is doing. It's gonna slice the path there, but I'm not really sure how is it possible that they put the same value for each one. They probably have the standard on the name or something like that. But I guess that's what makes sense, obviously, is that this is just gonna be the name of the folder, which is the name of the platform. Exports. Okay. Also, it does have this file here. It's just pushing to the list that creates here. I guess that it's just gonna get the path to the C++ files, if the platform has it, to later on parse everything to make part of the build system. I think this is just gonna return false when I'm building the way that I'm building. I'm not really sure though. I wonder how they did this as well. So they probably like either from what I've seen is a bunch of people that worked on this for a lot of years. So I'm not really sure if like each person worked on their own operational system and then each one did a little bit of each thing, or if it's just one person using virtual machines, because it is gonna be very annoying if I have to do that. And I think I'm gonna focus only on Windows and the operational system that I have here now, because it's just gonna be easier to build everything. But it is kind of tricky to think about like how later on I'm gonna build. But I think as long as I do it in the way that they did it here, probably it's gonna be fine. But I guess what is happening here is just figuring out what version of C++ compiler the path the Windows operational system has. It uses the OS to do that. It does feel a little bit hacky, this though. It's probably getting the name of the frame, which has the name of the relative path. So whatever script calls this file is going to be this path here, the directory of the path. It should be the root directory of the project because it's calling from here. And it does feel a little bit weird to do this. Just gonna ask ChatGPT as well. So I think it's building the binary folder path from here. So the final being directory from the project, this directory here. Otherwise, it's just empty. Outputs. I think these are just from scones, variables. You're just gonna create different types based on the arguments here. And so obviously, from the current build that I have now, is not using this stuff. Otherwise, there would be a build apps folder, I think, there on here. And it doesn't have any of this stuff as well.
To assure reproducible builds, SCONS uses a restricted execution environment for running external commands used to build targets, rather than propagating the full environment effect at the time SCONS install. This helps avoid problems like picking up accidental saves, temporary debug values that are no longer needed, or one developer having different settings than another, or than the C/CD pipeline. Environment variables that are needed for proper operation of such commands need to be set explicitly, which can be done either by assigning the desired values, or by picking values individually out of environment variables using the Python os.envar dictionary. The execution environment for a given construction environment is contained in its $env construction variable. A few environment variables are picked up automatically. See the section called environment. In particular, if the compiler or other commands that you want to use to build your target files are not in standard system locations, SCONS will not find them unless you explicitly include the locations into the path element of the execution environment. One example approach is to extract the entire path environment variable and set that into the execution environment. In particular, if the compiler or other commands that you want to use to build your target files are not in standard system locations, SCONS will not find them unless you explicitly include the locations into the path element of the execution environment. One example approach is to extract the entire path environment variable and set that into the execution environment. Import os equals environment env equals path os.environment path. Similarly, if the commands use specific external environment variables that SCONS does not recognize, they can be propagated into the execution environment. Import os equals environment env equals path os.environment path. Android underscore home os.environment android underscore home android underscore ndk underscore home os.environment android underscore ndk underscore home. Or you may explicitly propagate the invoking user's complete external environment. Import os equals environment env equals os.environment.copy. This comes at the expense of making your build depend on the user's environment being set correctly, but it may be more convenient for some configurations. It should not cause problems if done in a build setup which tightly controls how the environment is set up before invoking SCONS, as in many continuous integration setups. Note the above fragments are intended to illustrate a concept. It is normally not a good idea to wipe out the entire default value of the execution environment, ntenv, as it may carry important information for the execution of build commands. SCONS is normally executed in a top-level directory containing its construct file, the project directory. When SCONS is invoked, the command line, including the contents of the SCONS flags environment variable, if set, is processed. Command line options, see the section called options, are consumed. Any variable argument assignments are collected, and remaining arguments are taken as targets to build. Values of variables to be passed to the SCONS script files may be specified on the command line.
Still don't understand very well. I guess I have to read the stuff again there. What does that mean? Let me think about it. I have to spend some time thinking about this, what it means exactly. Okay, so they build the environment first because each operational system is gonna have specific things that they don't want to put manually. Okay. Prepend path should take a precedence or preserving SCONS on entries. So they're basically putting the path variable in the beginning, I think, of the dictionary, so that it has precedence over the other stuff. And I think I understand now, but I don't understand really well how this works. The environment thing. So if I understand correctly, I think what this is doing is just creating a virtual environment for scones. But I'm not 100% sure about the nuances of it. So the reason why they do things like the way they did there is so that scones handles the differences in the nuances in differences in operational systems, so they don't have to put some other code to do that. And then after they initialize that, then they prepend the path which is gonna put the thing on the first place on the dictionary. But like I don't understand why this is necessary or. I guess it's just easier to ask ChatGPT again. I think I get what is going on, but the issue is the nuances. So I guess that when you initialize this environment, you have to pass a path or something. It would be great if I could. Maybe I can look in the source code to see if I can find the definition of the thing. So another option is to see the use the where commands on to see where the installation of scones is, to try to find to open another VS Code thing to try to find the declaration of the class. So I want to understand if it's necessary to pass. I think usually the way it works is you initialize the class passing a dictionary with some information. So the main reason obviously should be because like usually there's a default way to do this, which is to pass the environment path here as a dictionary, and they are not doing this because when you do that, then scones is not going to handle some stuff that it usually does. So I'm trying to clarify what exactly does it figure out if you pass the environment path there. And the environment is going to be a Python class that is going to handle the logic for managing the environment and the options. I think it's just gonna, yeah, maybe. I don't think it makes sense to be the file there. It seems that it doesn't have. Unless it's on the end of the file. Oh, so it's the base thing. So I guess this is the main class, which is gonna be the environment class. It's probably just a waste of time though to try to understand, because it's probably gonna be. It's probably easier to read the documentation again, try to understand. Or just ask ChatGPT. Just pass this and ask ChatGPT. I probably not gonna spend a bunch of time on this, so probably not the highest or the most effective thing to do. And this doesn't explain that much. I'm gonna continue reading. It's probably gonna be clear, more clear later, maybe. And I guess usually you have so I think this is just gonna create a. I'm not really sure. I I was gonna say that this maps the path keyword or path string to the this place here, which is the current environment from the default, uh, the default path from this from the OS environment variables. But I'm not really sure if this is gonna be. Yeah, the problem is that I don't know what happens here. Based on the documentation here, seems like usually you pass a dictionary that's gonna map the path to the environment. And this path here is the one that is usually used by Python to figure out the executables or like the files that are gonna be the path of the files that are gonna be needed to run things. And based on the documentation here is not very clear how it works. So I guess this dictionary contains the variables that are used when you execute the scones command at the beginning. It's kind of confusing because of the other stuff there that was built in the like there's two different or maybe I'm confusing things. I need to spend some time thinking to clarify like what is going on the separation of things. Because there is the relationship between scones and the code that exists on this file and scones and the operational system. So the environment in which you're gonna run scones from, and then how scones is gonna deal with that environment to find the paths that usually the operational system is gonna store everything. So I'm not 100% sure. Like maybe I guess this is because of these things here. So yeah, this code is using the sys modules. So I guess this is what's kind of confusing. But I guess that class allows you to build an environment. So like it's two different things. So this sys here comes from the Python executable you're running, I think, to run scones. It's kind of confusing though. Like that's kind of the problem because in order to understand all this stuff, I'm gonna have to probably spend a bunch of time studying scones source code. I think that's the issue. The documentation is not gonna talk about this stuff. It's gonna describe how the things work, but not gonna talk about. Or maybe if I spend a bunch of time reading everything, then it's gonna become more clear how everything is connected. But I'm trying to think about what is the best way to go about it, about clarifying everything. So I guess, like, as far as I'm thinking now is that the OS and the sys is gonna be from the Python executable that is running. And then it's gonna build these things from using that, which are related to the paths of the platform there. And then these environments is gonna be like similar to using virtual env here to create a virtual environment, but it doesn't actually create any files as far as I know now. It just creates a class that is gonna work as if it is the environment. So that's what I'm thinking. And then usually, so it's probably creating the link between the current Python executable. Yeah, I think that's what's happening now that I think about it. So usually Python is gonna have the path environment variable as it executes, which is gonna be the path to libraries probably that's the current Python environment has. So the sites packages folder, I think, maybe. And it stores that on this path keywords. And then this is mapping that path, the standard Python path to the this path with this other environment path. So it's connecting them. But I still don't understand very well why, like, what are exactly the differences between initializing. So as it says there, it should be something to do with the operational system and the ways that's. But that's the problem, because to understand, I'm gonna have to go over the source code, I think, from scones. Not sure if it's worth spending the time now. Maybe some point. Because I need to understand what is gonna happen when the environment class is initialized, and how the logic is gonna change based on whatever operational system is running. And yeah. So the default's the execution environment, which is this thing. Yeah, so this just updates the environment class from scones with the shell path environment. So I think I asked this already. What is the point? I'm just gonna ask again. That's whatever. Oh no, here. Path.
The path environment variable is used to specify a list of directories where executable files are located. When you execute a command in a terminal or shell, the operating system searches for these directories listed in the path variable to find the executable corresponding to the command header. Here's how it works. Command execution. When you type a command in a terminal or shell, the operating system looks for an executable file with the same name as the command. Search path. The operating system searches through each directory listed in the path variable in order until it finds the executable file. Executable found. Once the executable file is found in one of the directories listed in path, the operating system executes it. In Python, os.getInPath retrieves the value of the path environment variable, allowing you to access and manipulate it within your Python code. This may be useful if you need to find the location of executables or manipulate the system environment in a platform independent way.
So it's used to find executables. So are default paths that it searches for. So it's probably the operational system environment path. environment variables path. Yeah, I think it's the operational system environment variables path. So it's updating the class with this environment path, and it's doing later because otherwise it's fucks up for other operational systems. So I'm just gonna go over, just follow, or I'll go over the other stuff, not spend too much time on this. But I should probably, I think what I'm gonna have to do eventually is to just, probably it's not a good idea to do this now. I think I'm gonna just try to make it work first and build the other stuff. And then maybe later to go back and study the source code for the first cons to understand exactly what is going on. So this file is changing the functionality from the environments. It's adding different functions to the environment class, I think. Yeah, so what is happening is just assigning variables based on the methods file there. So these functions are gonna allow them to change the functionality of the environment class, I think. It's gonna take some time, but I think it's not that hard to understand how it works. The hardest part, as always, is understanding the nuances of the connections of everything. And the biggest problem, this is a problem that happens like all the time. I think is the main fundamental problem with programming, which is the paradox of the black box, I think. So like the more abstractions you create, the harder it becomes to synchronize a network based on those abstractions. And I think that's mainly the learning process in programming is about that. So because people build stuff before you, and then it's more effective and energy efficient to use the stuff that they build, then what happens is there's loss of information because you're interacting with everything through the APIs that people build. And because you're building from the concept and you don't have the understanding of how the concept was built, it creates black boxes on your information you have on your mind. And the process of learning, I think, is just clarifying the black boxes, because it's more effective to use them because you don't want to spend a bunch of time reinventing the wheel. But then if you there's a trade-off that the more black boxes you use, the worse you become. And I think this is it's kind of the gradient that is going to determine how hard it is to learn everything. Because, and this is the main issue that I was talking about in the beginning, is that at one of the extremes is just using Godot straight from the editor. I think that's the far end of the extreme there, where everything is a black box for you. And even though you might be able to make it work, as soon as there is some mistake or some variance, then everything's gonna fall, because you're building things on a house of cards. So all your knowledge is built on abstractions that other people built, and is mainly black boxes for you. So you don't have the whole structure of the thing, how it's built. And I think this is the main problem I have with the both TypeScript and the way that people do documentation. Because they do it on a descriptive way, so like it's not the best, but obviously like they do it like this because it's easier, so it makes sense, and it is hard to clarify the black boxes, but most effective way is to bridge the gap between the interface of the API and the black boxes underneath. And the types don't help with that, and the documentation doesn't help with that, I think, from my perspective. So like you're just giving a description of the surface of how it works, but you're not explaining the complexity behind how the abstractions were created. So it doesn't it helps. It's only gonna help people that already understand the underlying thing, uh, which doesn't make sense. I think I'm gonna take a break now because the timer went and I'm already getting tired. But it's becoming more clear on my mind slowly how it works. But I still don't know. I don't have any idea how the third-party libraries are gonna be incorporated, but I assume that everything is based on this environment-based class. Then they have these other files that allow them to add some extra functionality to this class, and this functionality is the functionality that is going to be responsible for finding the CPP files that the project uses and compiling them. So I assume that probably they have, maybe they don't have on the external libraries that they depend on, but there should be one of the commands that uses glob or something like that to look for all the CPP files from the project, and then compile that into a library, and then link the library to the main thing. I assume that's what's going on. But I don't know how, at what point exactly are they doing this. I'm just gonna, so I think it's probably better to just, maybe next time I should think more about in the beginning. Yeah, but I think it's one of those things that's kind of a paradox, because like the main thing that I have to do is just clarify the questions first. I think that's the problem that I have here. I shouldn't spend too much time on this other stuff, because I should go, there's a principle from the book, 7 Habits of Highly Effective People. That's where I learned this from. I think it's a very good principle to have, which is begin with the end in mind. So you should always think from the end and then reverse engineer and go from there. So because it's always going to be a funnel whatever you're learning. So I think it makes more sense to go directly for this stuff that I'm interested on, and then from that point try to see how the connections are made. So the main thing that I'm interested on is the third parties thing, how they do it, and that's probably the thing that I should do in the beginning. So try to, or copy the folder that they have here, which holds all the libraries that they use, and then try to create a simple script from ascons that compiles that. So I have to figure out what are the nuances of the way that they are dealing with that. Maybe if I if I just search for this here. And the thing is, it might be on another file, or Python file, how they deal with this. Maybe there's one here. As then from the endpoints, this is the part I'm thinking now, is after you think about the endpoint, then obviously you're gonna face challenges. Then from the challenges, you think about the what questions to ask to guide the direction to clarify things. So now the question that I'm thinking about is whether or not Scones is gonna look for other. Based on the documentation there, it seems that it only looks for one file, but maybe it looks for other construct files on other directories. But I think it doesn't have any file, so. So obviously, if there isn't anything directly related to third party here, then it should be, it's either not going to be on the name or it should be on another Python file that is going to deal with this. Or it's not dealt with directly, it's just the thing that I talked about where it's going to use glob or something like that to look for all the CPP files. But it should have the name of the folder, I think, at some point. Unless it just looks from the root and it doesn't matter then. But then, like, how... I think that wouldn't make sense because then, like, it would be bad on the separation of things. I think it makes more sense that Scones is gonna build each external library as a DLL or a static library from C++ and then link that with the main project. But if that's the case, then there should be something here that is related to that. I guess just gonna keep following the thing and try to go faster. Interesting. So I guess it's just an optional file you can have here. And then it appends these other files. So variables is probably from Scones. It creates a variable that takes this on the arguments. It probably loops over this and then creates, not really sure, but whatever. And this is probably the list on the beginning there. Yeah. So has the options or the dictionary in the beginning. I'm gonna take a break and probably 20 minutes, 25 minutes. Then I'm going to continue to read this file here and try to understand. Probably gonna do 1 more hour after the break. And yeah, I want to understand first the third libraries thing. I think it doesn't make sense to try right away to copy everything because I don't know at what point. Maybe you should just copy the beginning of the file to see what happens there, like the part that creates the environment and stuff like that. But I think so far all the things that I've read are not related to the external libraries, and if they are, it's because it's through some thing under the hood that is gonna use some Python stuff to figure out the C++ files, but yeah, directly I don't think there is anything. It's mostly the stuff that is in the beginning here that is setting up everything on the Python environment and the modules and stuff like that to compile everything. I think there wasn't anything directly related to C++ yet, I think. So I'm just gonna continue to read this after the break, so I'll be right back. So I said I was gonna do 1 hour, but I'm only gonna do half an hour because I'm already tired. So just gonna put the timer here. Continue. Also, this is the first time that I've seen stuff related to C++. There's just specifying the flags for the compiler. Oh, there was some stuff related to some of the compilers and flags in the beginning, but I don't remember. Oh, stuff related to whether or not, yeah, it was on the text here. Yeah, so this stuff is related to C++. So when you're on Windows, whether or not you're gonna use what compiler you're gonna use depends on this stuff. I'm just gonna skip this stuff because, like I said, I'm interested on the third party thing. So here is the first time that's that I see this. Still don't understand though. I seem it's just appending the modules through maybe on the maybe they added Python files inside of the each thing. It's a free time. It doesn't look like it has anything. So if that's the case, then it should be. So probably later on it's gonna go over all the modules or something like that, and then for each one it's gonna do something. Just not directly related, but I don't like this that much to be honest. Maybe it's the best way to do it, but it looks like they are generating the shader codes through these files. Maybe they generate the header and they use they're just appending the header to the shader the same way that 3GS does. I don't like it because it makes it more confusing to. It makes it more difficult to change the shader code and more confusing to understand like what is going on. So I remember there is a part on the documentation that they talk about where they put the shaders, but I don't remember. There's something to do with the shaders, but I don't remember exactly what points they talk about this. I'm going to write down this stuff and then search later or read the documentation. So this is probably finding other sconstruct files and running them. Power builders. Oh, this thing. So this is probably the code that is building the commands for this specific build. I'm having a hard time thinking about whether or not it's worth it to use this because it seems like it's unnecessarily complex. That's the assessment that I have now, but it might be just because of the nature of building for several operational systems. Like if you have to specify all the files anyway, why not just use CMake? That's the question that I have, but not really sure. It might be just because it is complicated to do anyway, so. So the main thing that probably builds is this if statements on the. It has to be here. This. So before it just selects the platform, then here it does everything. But I don't understand. Like the only command that makes sense that is related is the VS project thing. But that's only for one build system, so I still don't understand. So for the VS project, makes sense that what is happening is they are building the code here that is gonna run things. I still don't understand how this code works. And I don't like this, to be honest. Because it just seems overly complex. Like, the thing is, like, why use this if it would be just as complex to do it with CMake? That's what I don't understand. So the only explanation is that it would be more complex to do with CMake, maybe. That's the reason why they did it like this. And for the other compilers, then I don't have any idea at what point the third-party thing, third-party libraries are gonna be parsed or compiled. I guess it could be on the other files there as well, on these types of files here that it has on a bunch of other places. This could be the. Oh, it's here, yeah. So I guess that's how they do it. So they build the environment class on the main S construct thing, and then from the environment class, they on the other files they structure how things are gonna be used. I think that's how it works. Yeah. Hmm. The only way to know for sure if it is like which one is the simplest way to do it would be if I look at other projects that are complex and cross-platform using CMake and then compare the two. But probably it's gonna be more complex because yeah, like it makes usually the projects are not even the cross-compiled projects they don't support many platforms because I think it's just an inherently complex thing to do because of the nuances of devices and everything like that. So it is probably like the simplest way to do it, but it's still very annoying to. But I think yeah, so far I think what is happening is this. Like in the beginning they build the environment variable class which has the configurations for the environment. Then they build the modules that the configurations need, which are the Python modules. Then from some point here they are gonna search for these other SC sub files, which probably is S construct for extra construct sub modules. Probably this is what this stands for. And then on each one of these files they're gonna have either they're gonna load other Python files to deal with the thing, or they're gonna deal with the third-party libraries for each thing directly here. And then after they do all of this, then they call. So at some point they call like the command line, or maybe ascons calls that at some point. I don't know. The actual command that is gonna run on the command line to compile everything, but I think that they're just building the commands based on whatever compiler you're using, and using glob to find the source files and header files to append or whatever. It's probably on the core. It's easier if I just look into this, but it's probably looking for this file. They're just gonna run this file whenever it has this command here, I think. It's just because of the name here. So I think this just runs as if it is one of these files, whatever you pass here. I think that's what's happening. So it just runs as if it is a X construct file based on the path that you. So you can pass any Python file, I think. They just do this name because it's easier to understand what is going on. Also, this depends is probably what is used to determine the dependencies. So it's using this to, which probably comes from here. So this is the main function that is gonna add the files manually, probably. Yeah, that's how they are doing. So they're just appending to the class based on this function here that is from the methods. And then on this SC stub files, they are getting all the third-party library files, source files, and then appending to the environment class. I think there's probably a way to simplify this, probably. That's the feeling that I have now. Because the thing that I dislike is that, like, each thing is on its own separate file, and I think it's kind of confusing too. The way that I'm thinking about it is just like, why not put everything on the like this main file here and like put all the dependencies on one file, all the third library dependencies on one Python file, and then build the paths that way. So that's what I don't understand, like why they did it like this. There are probably reasons, and obviously I don't know. Like I just learning this now, so but I'm not really sure if it's worth it to when I do my own thing there on the other project, if it is worth it to just copy the stuff that they like copy the parts of the code here that build the third party libraries, or if I should try to simplify right away. What I am thinking about doing is just putting everything on that file. So getting the parts of the code that use these third party libraries here, that build the environment variables with the third party libraries, just putting them on the Godot source files. Interesting. Just putting them everything on one file. But probably the reason why they do it like this is so that they can separate it by each module has its own thing. Probably. And it feels like it's not the best way to understand how it works. It feels like it could be simplified. And the other main thing that I don't understand yet is, but yeah, the thing is, it's probably scons that is gonna be responsible for this. Like, what is the final command? How does it build? And I think it's probably, it does it probably through the environment class, and that's the reason why they are appending here. They use these methods from the environment class, and after adding their own methods, and then based on some variable or something that's some logic that exists inside of the environment variable class, then scons is gonna, at the end of the execution there, is gonna build the final command to compile everything and link. So yeah, if I have to spend more time looking at all the other files as well. Yeah, the first thing that I want to focus on is just building. I think I'm just gonna try to build only with third library files. So, like, simplify everything. Try to simplify the commands there. In the beginning, just put the whatever is necessary. But the thing is that, yeah, that's this trade-off that I was talking about in the beginning. That's like the issue is that I'm gonna be using Windows 10 and the compiler that I have here. And the problem is that I might do something that works, but then I just fucked it up the other builds for the other systems. That's kind of the problem. So the question is, how do I simplify while making sure that I can add the other stuff later in the same way? That's kind of the hard part. But I guess the more that I understand the commands, the easier it becomes. You just have to write all the commands here and then read the documentation more to understand how they works. And after that, then I can think about how to simplify. And so this is one obviously probably as library. Oh, so you guys understand now why they're doing like this. So they're separating like this, so they separate the modules, and then they create a library based on the modules. So what I assume is happening is that each folder is gonna be its own module here, which makes sense because each thing is responsible for some parts of the whole thing. And then because each module is gonna use specific third-party libraries, then it doesn't make sense to build all of them, because then you would have to link all the third-party libraries to the main thing. But the way that they are doing here is they are building their own codes with the third-party libraries that the code relies on, and they are making that a library. So it's kind of like building. It's as if they're putting the CMake list file on each one of these folders here to build as if its own project, and then they're using add library command to link that folder to the main thing. So I guys understand now why they're doing like this. But the question is whether or not there is an easier way to do it, like a more simple. But the problem is probably the reason why they did it like this is that, like, if you put everything on a file, then it becomes harder to know. As you expand, as you create more folders and codes inside of each module, each folder, then it becomes harder to know what's third library the code is gonna use is associated, but I'm not really sure about this. So these are the main ones. I think that's it's clear now. Yeah, that's the thing that I just said is the correct thing probably. So on the main one, they're building the environment class. Then here in the end, they are running all the other scripts. And each one is gonna have its own module. So each one of these folders is like a separate. It's kind of like building a library. So in CMake, you use the add library command to build a library. And on C++, you can have static libraries or dynamic linked libraries. I don't know which one they're gonna build, like which one SCOM's build. It's probably static. Static is one that is part of the code, and dynamic linked library is one that the operational system loads, and then it can be used by several different programs. So each one of these here is as if using this command here. And then each one of these folders is going to use their own their own third-party libraries. And that's the reason why they separate like this. So in each one of these is going to build based on the methods that it has here that I appended to the environment in the beginning. It's going to parse through the paths and put them as part of the environment, as part of the build of the library. Then at the end of each one of these, it builds the library, and then it links that with the main thing. I think that's what's happening. Yeah, so at the end here, it just adds the library to the environment. Another thing that I can do that I remember is that after I can just rebuild and then put a bunch of print statements to see if they're gonna show there on the. And the problem is that there's a lot more things that show here, so I'm not pretty sure if I'm gonna be able to see. I can put breakpoints or stuff like that. Yeah, so it is static libraries. They're creating static libraries. So the one of the main questions is how does SCOM create the final build command? Oh. This is the so I'm wondering whether or not you need to like call something on the environment to create the final build to make scons run the command that is going to compile everything, or if scons does that automatically after it executes these sconstruct files based on the state of the environment class. I'm thinking that's probably the second option because it doesn't. It seems that it doesn't have anything here that explicitly calls something, but the only exception is this for the Visual Studio project. But I assume that this is probably the files that are generated for the XML files that Visual Studio project generates, and not the compilation itself. I don't know exactly the nuances, but I think that Visual Studio Code uses XML files to generate the build. They compile, but is not the files are not the thing that compiles the thing. It just uses the files to compile. So I think that this is just generating the necessary files, but it's not compiling anything. If that makes sense. Maybe it's on the Windows folder. And doesn't have any files here. I guess it's because I didn't set this thing here. So probably if I pass that as a command on the command line argument here, then it's gonna generate the files, I think. It's already here. I'm gonna go from the other part that is kind of annoying is this shader thing here. I don't understand how this works very well. So I'm gonna go from the ends there, see if there's a... This thing, it seems like it's not related to just checking to see if it fails, but not related to actually running the compilation. Let's start checking for the times. It's creating a JSON file. Also, it did great here. Or maybe he uses this JSON file. I think it doesn't use this, it's just optional to... So, like you can see what configuration it has. It doesn't seem like it has anything explicitly compiling. Maybe it has on the other ascons files though. I don't think it does. So it's probably something that ascons does after it executes all these files. It just based on whatever state the environment class is at, it's just gonna build the command based on that, I think. So I'm gonna stop streaming and I'm going to read the documentation of to understand what these commands do. And the more I say clarify everything, then I go back. I think probably what I'm gonna do is just copy the not. I think the configurations is better to copy because all this stuff is related to flags of each, depending on what compiler you're using, what kind of flags you want. So I don't see. So I'm gonna copy everything here. I'm just gonna copy this file to the other project, and then I'm gonna have to spend some time thinking about it because I have to understand. Probably I'm gonna watch the videos again for the source code files because I have to understand which one of these folders is the more, which ones are more fundamental to what I'm trying to do, and the difficult part is gonna be to figure out in the beginning how to do it because I don't think I'm gonna be able, based on the stuff that I've seen here, I'm not gonna be able to just put all the third-party libraries there and then rebuild because of the way that they do things there. So I have to figure out which one of these folders I want to try to implement first. It's probably gonna be the main, but the thing is, if I do it, that's the problem. If I do it with the main first, then yeah, I'm not really sure if it's gonna be possible to. Unless I delete a bunch of the code. But obviously, the flow of execution starts with it starts with the platform, then goes from the main that is gonna have stuff related to the drivers to figure out which renderer it's gonna use. Then after that, I think it uses the core. Core is where the main stuff is at. The editor is just the code related to creating the editor, obviously. These modules they're optional based on the documentation. What I remember, they are optional modules. So probably this is the last thing that I'm gonna do. And I'm not really sure if the platform. I think I don't remember really well if the platform is the main entry point or if it's the main functions. No, I think, yeah, the platform has the class that is related to handle. So the main is the main entry point, the main folder. It's the main entry point that has the functions that are going to initialize everything. And then the platform contains the code related to the platforms that is going to deal with the paths and other stuff like that to create the servers and to do other stuff. Yeah, so this is, I remember that this is one of the functions. I put breakpoints here. The main loop is the class that is going to run the loop. It's going to contain the state of the loop. And display server is the class that initializes the window for the first time. So the window initialization and the other stuff related to the operational system is on the platform. So the main one is this one, the entry point is this file here. But the issue obviously is that this file is related to everything else. So if I just straight up copy this, then it's just gonna give me a bunch of warnings. I'm gonna have to copy everything. So I think probably the best thing to do is just to go with the debugger first, and then the thing is, like, it's gonna take a lot of time to maybe just do the function names, the execution to create a flowchart here. So the way that I was thinking about it is just like I probably I try to reconstruct the whole flow of execution, but without a bunch of stuff. Like just remove most of the stuff and just rebuild the main functions that are run. And then as I build the main functions, then look into what kind of third-party libraries are necessary to run each I think that's probably the best way to go about it. Because by doing that, then it's gonna force me to understand why certain libraries are being used. And then as I do that, I'm gonna create I think I'm just gonna copy this file, but then I'm gonna remove or comment out the SC sub files that add third-party libraries and all the other Python files as well that I don't understand. And then it's gonna force me to figure out. Yeah, but I'm gonna stop here. Probably next time that I stream, I'm gonna do this. So just copy this file, then think about one by one, starting from the main file, the main folder. You just copy this folder and then remove a bunch of things from the functions. Just get the main functions that are run, remove most of the stuff, and then try to rebuild the commands, adding one thing at a time. And I'm gonna do this just enough so I understand, like, to get more clarity on how exactly everything is connected and how does it work. The only concern is the amount of time it's gonna take, because there's a bunch of stuff to. Like, I went with the debugger already at some point, and just the initialization parts there to structure everything is already like a lot of code, so it took me a massive amount of time just to go over the. But it's always like that in the beginning of anything you're gonna do, because obviously you have like a bunch of stuff you don't know. So usually that's how it works. Like in the beginning it's very, very hard, but then as time passes it becomes a lot easier because you become familiar with the functions that are being called, and there are several different functions that are gonna be called all the time. So I can skip them next time. But I'm not really sure if I'm gonna go all the way of trying to rebuild everything. So I'm just gonna do it enough so I clarify how they went about doing things, and then from that point I think I can. At that point I would decide either if I should. I probably am gonna build stuff with Godot first. Godot, however you say that. From the editor directly without doing anything with the engine, just so I understand how the scripting works and how to build something simple with the editor. Then after I do that, then I can decide, I think, whether I should just get the stuff that I think is good from what they did and try to merge that into the stuff that I was gonna. Because one thing that I can do is just get the engine function, both the memory optimization things. They use mutex as well, because they're doing multi-threaded stuff, and also the server as well. Server is really important and is very hard, and it's something that I was planning on doing later. But obviously, I can just get all these other parts that I don't have there, because basically I only have the rendering and only the beginning of the rendering on the other one. So I could try to incorporate that on the other one that I have there already. Or I can just try to reconstruct everything. Because the main thing that I'm trying to achieve is to be able to customize the thing. So I want to be able to do whatever, like not have to rely on their editor or stuff like that, and to be able to do it if I want to do stuff directly from the code. From the engine itself, and not have to use the editor at all. So just use, ideally I would be able to just use everything with functions, because the stuff that I'm thinking about doing is gonna require gathering a bunch of data, and I'm not really sure how it's gonna scale, and I think it's gonna be very complex. So, but obviously you can always put the functionality on the editor as well, but it would be better, I think, if I could do straight from the code instead of having to rely on the editor to build everything. This is the main function that is going to set everything up, then initialize the engine. Maybe instead of getting the classes, getting the functions, like I said, it's probably better to get the classes first. Try to compile the classes. It might be a better idea. And there's also the database that they use to register things. So this is the main function. This is where it's going to create the window. And I guess I think it depends on the driver, which is set up based on the platform that you have there. It's going to be on the OS. Which is the part that I was doing here, I think. So in one of these functions is stores what kind of function you call there, I think. When it calls this display server window or display server something. Yeah, so it puts this function there before the setup, and then this is the main one. This class here is gonna build the window, and this is the custom memory allocation. So this is one of the classes that gets called all the time. Maybe I can do that. I think probably that's a better thing to do. So yeah, usually it's going to go that way, which is just the 80-20 rule. So 20% of the code is run 80% of the time. So what I can do is just spend a bunch of time going over again with the debugger. I think that's probably a better idea. So just spend a bunch of time going with the debugger and write down and start putting breakpoints on the functions that are called most often and write them down. Then after I have that, then I should transfer those functions first to the other project. And that's probably a better idea. And then from those functions, I can see if I can compile them or... Yeah, I think that's what I'm gonna do. I'm gonna put there. And then it's probably a good idea to spend a bunch of time studying their source code as well, to understand, especially this memory that I thought is really interesting. There is a very good video of the guy explaining. If you search for the names there, like I said, of the Godots, you're gonna find on YouTube some of the guys. Some don't remember which guy it is, but he explains the memory thing, why they did the memory the way that they did. Thought it was very interesting. So I'm gonna remove this thing here. So I'm gonna spend a bunch of time going over the debugger and then write down here the ones that I see most often. This one. And this one is I see it all the time. So I'm gonna write the classes and the functions. Then after I do this, I can do the other. So after I do this, then I copy main as construct file. That's probably the best approach. I think that's I'm gonna remove this because it's probably probably what's gonna happen is I'm gonna face a bunch of challenges and then I'm gonna have to rethink the approach after this step here. So I'm gonna stop streaming and study this stuff on the documentation, and then probably I'm not sure when I'm gonna stream next, but probably I'm gonna continue to do this thing here. So the goal now is to either merge Godot, break down Godot and get the useful stuff that I think I can merge with the other project and then merge, and then continue with the project that I was doing, or just try to copy as many things as possible and then just understand the code well enough so I can customize however I want, and then continue to build the stuff that I was trying to build.